Alright, so this is a continuation of the last video where we went through the procedure of being able to solve polynomial equations, and we saw this example here, and now we're actually going to solve this example. So in order to solve this polynomial equation, step one says we're going to solve for 0 on one side. So we're going to set one side of this equal to 0. So we have to subtract x to the fifth, we have to subtract 5x to the fourth, and we have to subtract 7 because we have to cancel all this stuff. So we're going to minus x to the fifth here, and when we do that, we also have to minus x to the fifth over on this side because it's an algebraic equation. We got it. Whatever we do to one side, got to do the same thing to the other side. Minus 5x to the fourth. So over here, we're going to minus 5x to the fourth minus 7. So here, because it's a like term, we're going to minus 7. I'm going to draw a line here. Okay, bring down the equal sign. 4x to the fifth minus x to the fifth is 3x to the fifth. 9x to the fourth minus 5x to the fourth is plus 4x to the fourth. We're just going to bring down the minus 10x squared. We're going to bring down the minus 19x. And then here we have negative 3 minus 7, which is negative 10. And then this cancels, and this cancels. So we have 0 on this side. And that's what we're supposed to do in step one. Okay. Then what we're supposed to do is, looking at the polynomial side, we have to identify the list of all possible rational roots. Okay. So by the rational root theorem, we're going to make a list of possible rational roots. Okay. Now, in order to make this list of possible rational roots, we need to identify the p's and the q's. Now, the p's are the factors of the constant, so the factors of 10. Now, we can ignore the negative for now because we're going to do the positive and negative of every factor. So let's just say, well, what are the factors of 10? Well, we know 1 times 10 equals 10, so that's 1. We know 2 times 5 equals 10, so 2. Like we said, 2 times 5, so 5 is a factor, and because 1 times 10 is a factor, 10 is also a factor of 10. There are no other factors. It's 1, 2, 5, and 10. Okay, and then we're going to identify the q's. Now, the q's are the factors of whatever the lead coefficient is. The lead coefficient is 3. The factors of 3 are just 1 and 3. And now what we're going to do is we're going to take each one of the p's and make a fraction where this is the numerator and these are the denominators. So for example, we're going to do 1 over 1. Well, 1 over 1 is just 1. So one of our possible rational roots is 1. And if 1 is a rational root, then negative 1 is also a rational root, okay, or a possible rational root. Now we're going to do 2 over 1. Well, 2 over 1 is just 2, and then we're going to do negative 2. We're going to do 5 over 1. Well, that's just 5, and so we're also going to do negative 5. We're going to do 10 over 1, and so that's 10, and we're also going to do negative 10. Now we're going to do each one of these numbers over 3. So 1 over 3, negative 1 over 3, 2 over 3. So let's just write those out. So we got 1/3, negative 1/3, then 2/3, 2/3, then negative 2/3, then 5/3, 5/3, then negative 5/3, then 10/3, 10 over 3, and then negative 10 over 3. There we go. This is our entire list of all of the possible rational roots. And so this is our list that we're going to work through and cross them off. Okay. So what I'm going to do is I'm going to move this list maybe to the top, and then I'm also going to move this polynomial. I'm going to kind of move that over to the top too as our starting polynomial. Okay, now step 3 says that we're going to start going through this list of possible rational roots, and we're going to try and cross some of them off by doing synthetic division. So we'll start with 1. We'll put 1 in a half box, and we'll use this polynomial. We're going to do a 3, 3x to the fifth, then a 4, 4x to the fourth. Now, notice we skip x to the third. It goes from 4x to the fourth to minus 10x squared. But we have to put a 0 in for 3, for x to the third. We can't skip a power. So we're going to put a 0 in for x to the third because there is no x to the third. That means the coefficient of x to the third is 0. Then we'll put in a negative 10 for x squared, then a minus 19 for x, and then for the constant, we'll put in negative 10. And now we'll do synthetic division. I'll draw my horizontal line, put a 0 here. 3 plus 0 is 3, times 1 is 3, plus 4 is 7, times 1 is 7, plus 0 is 7, times 1 is 7, plus negative 10 is negative 3, times 1 is negative 3, plus negative 19 is negative 22, times 1 is negative 22, plus negative 10 is negative 32. So you can see now that our remainder is not 0. Not 0. And therefore, we can cross off 1. That's not going to be one of our that's not going to be one of our roots. So now we're going to move on to negative 1. All right, so we'll do negative 1 in the half box, then a 3, a 4, a 0, a negative 10, a negative 19, a negative 10, and then we'll draw a horizontal line, put a 0 here. 3 plus 0 is 3, times negative 1 is negative 3, plus 4 is 1, times negative 1 is negative 1, plus 0 is negative 1, times negative 1 is 1, plus negative 10 is negative 9, times negative 1 is 9, 9 plus negative 19 is negative 10, negative 10 times 1 is 10, and 10 plus negative 10, that's 0. So look at that, we've got a remainder of 0. All right, so what step 3 says is we're now going to make our list of roots. So over here I'm going to write roots, and I'm going to say that one of my roots is going to be negative 1. So I'm going to put a negative 1 right here in my list of roots. It also says that I need to make a list of factors. So I'm going to write factors, and that my factor needs to be x minus whatever the root was, whatever the candidate was. Well, that's x minus negative 1, and x minus negative means x plus 1. Okay, so this factor is going to be x plus 1. And then step 3 says that I need to take this bottom line here and I need to write out the reduced polynomial. Well, in order to know what the first thing is going to be, I have to look at the original. Originally, I had 3x to the 5th power. So this is going to now be 3x to the 4th power. Then this 1 is going to be plus 1x to the 3rd. But I'm not going to write the 1. I'm just going to write plus x to the 3rd. This negative 1 means negative 1x squared, or just negative x squared. This negative 9 means negative 9x, and then minus 10. And so this down here, this is my reduced polynomial. Okay, this is what I mean by a reduced polynomial. I had a 5th power polynomial, and now I have a 4th power polynomial. It has gone down by 1 power. It has reduced. Okay, where is that 1 power? It's over here. It's the x plus 1 that I factored out. Okay. So then step 3 says that if this is a quadratic, it's not. If it's a quadratic, to skip to step 5. But I'm not going to skip to step 5 because this is not a quadratic. So we're now going to move on to step 4. All right, so step 4 says that I'm now going to try the same number that I just tried. So this root that I just found, negative 1, I'm going to put it in the half box again, but I'm going to try it on the reduced polynomial. So instead of using 3, 4, 0, negative 10, I'm going to use 3, or positive 1, negative 9, and negative 10. So 3, 1, negative 9, and negative 10. And you'll notice that these are the same numbers that were the bottom line on the last synthetic division I did. And I'm going to do it again. So why? What am I doing? Well, it's possible that x plus 1 shows up twice as a factor. And if it does, I need to record that. So that's why I have to try this negative 1 again. So I'll put a 0 here. 3 plus 0 is 3, times negative 1 is negative 3, plus 1 is negative 2. Negative 2 times negative 1 is 2, plus negative 1 is 1, times negative 1 is negative 1. Negative 1 plus negative 9 is negative 10. Negative 10 times negative 1 is 10. And sure enough, negative 10 plus 10 is 0. I got another remainder of 0. That means that -1 shows up as a root 2 times, and it shows up as a factor 2 times. So what I have to do is I have to record it again under roots -1. I mean, I don't really have to. You don't have to record duplicates. I'm just trying to follow the procedure that I set up. But I do have to record the factor again. I have to record x plus 1 as another factor. So far, the multiplicity of x plus 1 is 2. And so now what we have to do is repeat step 4. We have to, well, first it says to take our bottom line here and rewrite it as a new reduced polynomial. So we had x to the 4th. Now this is 3x to the 3rd minus 2x squared plus 1x, or just plus x, and then minus 10. There we go. And then we recorded our factor, we recorded our root, okay? And so now what we're supposed to do is we're repeating step 4, and that means we're going to try -1 again. So we're going to put -1 in the half box, but now we're going to use these numbers. We're going to use 3, -2, 1, and -10. 3, -2, 1, and -10. Draw my line. 0 plus 3 is 3, times -1 is -3, plus -2 is -5, times -1 is 5, 5 plus 1 is 6, 6 times -1 is -6, -6 plus -10 is -16, and now you can see that my remainder is not 0. Therefore, -1 is not showing up again. So now what I'm going to do is I'm now going to move on to the next number in the line, and I'm going to test 2. What am I going to test it on? I'm going to test it on this polynomial, the reduced polynomial. All right, so I'm going to put a 2 in the half box, and then I'm going to use 3, -2, 1, and -10. Draw my line. 0, 3 plus 0 is 3, times 2 is 6, minus 2 is 4, times 2 is 8, plus 1 is 9, times 2 is 18, and 18 minus 10 is 8. So my remainder is not 0, and therefore I'm going to cross off 2, and now I'm going to try -2. So I'll put -2 in the half box. I'll use these same numbers because I haven't reduced the fraction or the polynomial yet. -2, 1, -10, draw a line. 0 plus 3 is 3, times -2 is -6, plus -2 is -8, times -2 is 16, plus 1 is 17, times -2 is -34, plus -10 is -44. Therefore, -2 not equal to 0, or does not have a remainder of 0, so we're going to cross off -2. Moving on to 5. All right, here we go. 5. We're going to put a 0 here. 3 plus 0 is 3, times 5 is 15, minus 2 is 13, times 5 is 65, plus 1 is 66, times 5 is 330, minus 10 is 320. Once again, remainder not equal to 0. All right, let's try -5. -5 in the half box. We got a 3, a -2, a 1, a -10. You might be thinking, oh man, this is a lot. I know. And the more you do it, the better you'll get at it. But this is the job. This is what has to be done. Put a 0 here. 3 plus 0 is 3. Times -5 is -15. Plus -2 is -17. Times -5 is 85. 85 plus 1 is 86. 86 times -5 is definitely not equal to 0. Let's just skip it, okay? Cross out the -5. Now we're going to move on to 10. So we got 10, and then we'll do a 3, a -2, a 1, a -10. Draw a line. Plus 0 is 3, times 10 is 30, minus 2 is 28. 280 plus 1 is 281, times 10 is 2,810, minus 10 is 2,800. Not 0, so we don't need 10. Now let's try -10. -10. 3, -2, 1, -10. Oops, sorry about that. -10. Draw our line. 0, 3 plus 0 is 3, times -10 is -30, minus 2 is -32, times -2 is, or -10 is positive 320, plus 1 is 321, times -10 is -3,210, minus 10 is -3,220, which is not 0. So Now we got to start moving on to the fractions. All right, so we're putting a 1/3 in the half box. You might say, you can put a fraction in there? You bet you can, and it's going to work out very nicely because we have this 3 here, so it's always going to work out okay. All right, so 3 times 1/3 is 1, and 1 times -2, or 1 plus -2 is going to be -1. -1 times 1/3 is -1/3. This is not looking good. Plus 1 is going to be +2/3. +2/3 times 1/3 is going to be 2/9. This is, look, I don't know what this is, but it's not 0. So let's move on to -1/3. All right, so let's draw our line. Put a 0. 3 plus 0 is 3 times -1/3 is -1. -1 plus -2 is -3 times -1/3 is +1. 1 plus 1 is 2, and 2 times -1/3 is -2/3, which is, again, not 0. So let's now try, let's cross off 1/3, cross off -1/3. Let's try 2/3. All right, we'll put a 0 here. 3 plus 0 is 3 times 2/3 is 2. 2 plus -2 is 0. 0 times 2/3 is 0. 0 plus 1 is 1. 1 times 2/3 is 2/3. And 2/3 minus 10 is not 0. All right, we're going to try now -2/3. All right, we'll put a 0 here. 3 plus 0 is 3. 3 times -2/3 is -2. -2 and -2 is -4. Times -2/3 is +8/3. +8/3 plus 1 is 11/3. 11/3 times -2/3 is -22/9. Minus 10 is not 0. So we're crossing out -2/3. Now we're going to try 5/3. All right, we'll put a 0 under the 3. 3 plus 0 is 3 times 5/3 is 5. 5 plus -2 is 3. 3 times 5/3 is 5. 5 plus 1 is 6. 6 times 5/3, so 6 times the numerator, 5 is 30, divided by 3 is 10. So put a 10 here. Minus 10 is 0. Yay, we did it. We found one. So the next one is 5/3. So we're going to put a comma here, and we're going to say that 5/3 is a root, and then we're going to say that x minus 5/3 is a root, or is a factor. Let me make that a 3. There we go. Cool. Now I have good news for you. Look, step 4 says if at the end of this process you have only 3 numbers at the bottom plus your remainder of 0, now you can move on to step 5. So the reduced polynomial is now 3x squared plus 3x plus 6. And so this is a quadratic, and now we can move on to step 5. All right, so the first thing it says is if this is factorable, then go ahead and factor it. It is not factorable. Now, there's a way to determine whether it's factorable. One way is by using a graphing calculator. And for example, Desmos is a graphing calculator. And if you see that the zeros of the polynomial are like whole numbers or like terminating fractions like 0.25 or something like that, then it's factorable, okay? But this, if you were to put this in Desmos, you would actually see that it actually doesn't cross over the x-axis at all. So it's actually, it doesn't have any zeros. But I'm going to prove that to you. We're going to use the quadratic formula. We're going to say a is equal to 3, b is equal to 3, and c is equal to 6. And now we're going to do x is equal to negative b, which is negative 3, plus or minus the square root of b squared, that's 3 squared, minus 4 times a, which is 3, times c, which is 6, all over 2a, which is 2 times 3. And so what we have here is x is equal to negative 3 plus or minus the square root of, well, 3 squared is 9, minus 4 times 3 is 12, and 12 times 6 is 72, all over 2 times 3 is 6. Now look at this, 9 minus 72. This is a negative number. So we have negative 3 plus or minus the square root of, what is that, negative 63? Negative 63 all over 6. And we know that when the discriminant is negative, when we try to take the square root of a negative number, that means that there are no real roots. And therefore, we can say that there are no real roots to this quadratic. And so we're done with our list of roots. This is our whole list of roots. Then, step 5, if you look back at your notes, it says that you're going to take this quadratic, and that is now one of your factors. So as one of our factors, we're going to put in 3x squared plus 3x plus 6 as one of our factors. And so then if you look after step 5, how do we finish up the problem? Well, the first thing we're going to do is take all of our roots, and if we have any duplicates, we're going to ignore them. So we have two negative 1s, so we only need one of them, so we're going to get rid of one of them. And so really, our solutions are -1 and 5/3. That's the answer to this problem. Look, it says solve for all the values of x. So one of them is x equals -1, and the other solution is x equals 5/3. And that's the end of the problem. But I will say this, if you wanted to write the polynomial in factor form, you would write all of these factors next to each other. But here's the problem. Look at the very last thing from the previous video. We're not supposed to have fractions. Do you see this x minus 5/3? It says if that happens, then whatever the denominator is, 3 can be factored out of another factor. We can actually factor a 3 out of this. This 3x squared plus 3x squared plus 3x plus 6, we can factor out a 3 because we can do divide by 3, divide by 3, divide by 3. And we wind up with 3 times x squared plus x plus 2. Then we take this 3 and multiply it by x minus 5/3. So I'm going to, I don't know, let me erase something here. Let me make some room. I'm going to get rid of this quadratic formula here that we used. And look, what I'm going to do is I'm going to leave this. So we have x plus 1 as a part of our factored form. We have another x plus 1. And then we also have this x squared plus x plus 2. And then we're going to take this 3 and multiply it by x minus 5/3. 3 times x minus 5/3. So this is going to become 3x. And then 3 times negative 5/3 is just minus 5. And so this is our last factor, 3x minus 5. 3x minus 5. And this is the factored form of the original polynomial that we started working with. Okay? All right, so this example, this is an example of how to apply the procedure that we learned in the last video. I'm now going to do probably 1 or 2 more videos that include examples so that you can build your confidence.